Please take out the 13.1 note packet you received. Today we're going to go over 13.1 notes. The objective is students will be able to identify cycles and periods of periodic functions and define the amplitude of periodic functions. The homework is going to be the 13.1 worksheet. So on my first slide, I'm going to start off with a few definitions. So a periodic function is a function that repeats a pattern of y values or outputs at regular intervals. Again, a periodic function is a function that repeats a pattern of y values at regular intervals. I'm going to give you an example and a non-example. So, let me change colors here so you can see it better. If I have, or on a graph, I'm going up to the exact same heights in repeated intervals, then that is what we call a periodic function. Here is a non-example. Even though there appears to be a pattern, do you see that I don't have the same y values, the same heights? Okay, a y value is how high it goes. Remember, y values are your range. So that's a non-example. I have a repeating pattern, but it's not just a repeating pattern. It's a repeating pattern of y values or outputs. One complete pattern is a cycle. One complete pattern is a cycle. A cycle may begin at any point on the graph of the function. We're going to do several examples where we practice this idea. The period of a function is the horizontal length. The distance along the x-axis. The period of a function is the horizontal length, the distance along the x-axis. The x value in a periodic function often represents time. At any point during the video, please pause it and think about what we've just written down. The essential understanding is periodic behavior is behavior that repeats over intervals of constant length. And again, we'll look at some examples to help us with this. So periodic functions are functions that repeat a pattern of y values at regular intervals. So on this next slide, I really want you to look at the math usage. The period of a function is the horizontal length of one cycle. A periodic function is a function that repeats a pattern of y values at regular intervals. We'll see a little bit later something called the amplitude of a periodic function. And the amplitude of a periodic function measures the amount of variation in the function values. What's really neat is every year in January, the Columbus Dispatch will plot the temperatures in Columbus, Ohio. And it actually makes a periodic functions. It'll go low to high, back, down, and it repeats every year. It's really neat. When we analyze the period of a function, we can use two methods. You can trace, and you can look at the beginning and ending values of the periodic function. So let's actually do this. So when you're ready, flip the page. Again, pause at any point if I'm going too quickly for you. So letter A says trace one period of the function with a different color. So I like to start at x is 0. And I want you to use your pencil or pen, use a different color. And if I trace along here for one cycle, it would stop right here. So this has x equals 0 is the start to x equals 4 is the stop. Now, I could do this another way. I could find another spot. Do you see if I start down here at x is -1, I could trace x equals -1 until it's going to start repeating. And so I could also do x is -1 to x is 3. So that's one full period length. Or think of it like that you had a stamper, like you had a stamp. And if I could take that stamp and keep punching that stamp, how long would it have to be until you were just repeating that piece of the curve? Now, the period length is the distance between the start and the stop. But what you do is you do the stop minus the start. So if I do 4 minus 0, that's 4. If I do 3 minus -1, that is 3 plus 1, which is 4. So the period length is 4 units. And if you remember, on our first slide, we said that the period length is the horizontal length, the distance along the x-axis. So from x is 0 to x is 4, that's 4 units on the x-axis. All right, example 2. It says trace one period of the function with a different color. So let's say we start at x is 0. Again, I love that. I love starting at x is 0 because it's very easy to figure out the period length. So go ahead of me, and I want you to try from x is 0, use your pen or pencil, trace it till you think it would start repeating. So here's one way, x equals 0 to x equals 3. Another one, and this is what it says in part B, like couldn't I start at x is -1 and go to x is 2? So my period length is always going to be the stop minus the start. So it's way easier to do it from 0, okay, that's easier. But notice no matter which kind of chunk of the graph I think I'm going to repeat, I'm still going to get a period length of 3 units. Just a word of caution, check the x-axis and make sure that the tick marks are going by 1s because they don't always go by 1s. All right, in example 3, it says, is the function below periodic? Explain. Pause the video and I want you to think. Seriously, pause the video. All right, now that you're back with me, the answer is no. It is not periodic because the y values do not repeat. There is definitely a pattern. Okay, there is a pattern, but I don't all the y values have to go up to the same height, to the maximum, and to the minimum values. So that's a no. All right, example 4, this looks actually like the exact same, doesn't it? So it's a no. All right, go ahead and flip the page for me. And we've got some more vocabulary to fill in. So let's start with this first definition. The midline is the horizontal line midway between the maximum and the minimum values of a periodic function. So that makes sense why it's called the midline. It's a horizontal line, and let's write ourselves a note. Horizontal lines, look like y equals a number, like y equals 2, y equals 3. So the midline is the horizontal line midway between the maximum and minimum values of a periodic function. The amplitude, and remember I told you we're going to talk about this concept, so now we're ready. The amplitude is half the difference between the maximum and minimum values of the function. So let's look at this graph here. What is the maximum value? Well, the maximum value, the minimum and maximum are y values. So I want to pause here a moment to make sure I distinguish between period and max and min. Period, we use the x values to determine it, but maximum and minimum values are y values. So that's very important. So I'm going to look at my graph, and on this video you can see that the maximum is the blue dashed value, so that's up at 1. My midline is the middle between the maximum and the minimum. So here's a case, and this is why I mentioned previously, do you see this tick mark? I'm going by ones. Okay, I'm going by ones on the y-axis as well as the x-axis. My midline is gray, and it's halfway between 0 and -1. So the midline is y equals -1/2. The minimum value is -2. So let's look at the slide below, and I put formulas here, and you do need to just remember these, and I believe we'll do enough practice to remember them. It's the same graph as above. It's a little bit bigger on the previous slide, but example 5 goes with the graph above. It says find the amplitude of the function, and the amplitude is half the difference between the maximum and the minimum value. So we abbreviate amplitude as amp. So it's 1/2, and we put this above, it would be 1 minus -2. So the amplitude is half of 3, or 3/2. You can say 1.5, that is okay. The equation for a midline is y equals 1/2 the maximum value plus the minimum value. So there is a formula for it, or graphically you can just figure it out. It's going to be y equals halfway between the max and min value. So this one's going to be y equals 1/2 times -1, and this is what we wrote above. It is y equals -1/2. Again, amplitude is 1/2 the difference of the maximum minus the minimum. The midline is y equals 1/2 the max plus the min value. All right, example 7. Find the amplitude of the function and the equation of the midline. So what I would like you to do is I'd like you to pause the video here, look back at the previous example, and see if you can figure this out. Then press play and watch me work it out and confirm what you have. So what I like to do here is I like to determine the maximum is 4. And notice it's 4. Remember I said to you, be careful on your tick marks. They're not always 1. You have to pay attention. So on my y-axis, I have 2 tick marks. So it's 2, 4. So each tick mark is going by 2's. Then my minimum is -2. So when you want to find amplitude and the equation of the midline, identify the max and the min. The amplitude is 1/2 the difference, 4 minus -2. That's 1/2 of 6, so the amplitude is 3. The midline is a line, so be careful. Amplitude is a number, and the midline is an equation, because it's a line, so it's different. So this is y equals 1/2, and I'm going to take 4 plus -2. So that's 1/2 of 2, which is 1. So let's draw the midline, would be halfway between 0 and 2, and that makes sense. Because from 4 to -2 is 6 units, so I want to go down 3 from the top or 3 from the bottom. All right, letter B. Again, looking carefully at my scale, I'm going by 2's on the y, so the maximum is 3, and the minimum y value is 0. The amplitude is 1/2 the difference between the max and the min, so the amplitude is just 3/2. The midline is an equation which is 1/2 the sum of the max and the min. So this is y equals 3/2 or y equals 1.5. Let me make sure we're kind of getting the gist of this. Let's go back to the period lengths. So in letter B, do you see if I started up here at x is 0, it's going to repeat here. So I could start at x is 0 and go to x is 6. So the period length is 6. Here, now this one has a longer cycle. Do you see it really is periodic? So let me use green here. I can go to x is 0 and it'll repeat at x is 10. So the period length here is 10. That's kind of cool. All right, so you can have period cycles that are longer, but as long as the whole thing begins to repeat and repeat and repeat, then it is periodic. So, determine if the function is or is not periodic. If it is, find the period. So what I'd like you to do is pause the video and try this. All right, number 1. This is yes. It is longer, but it's going to go from here to here before it repeats. So it starts at x is 0 to x is 5 to do the period length, and oftentimes we abbreviate that PER. It would be 5 minus 0, which is 5. Number 2, this one does not repeat. Do you see it's going up forever on the left side and up forever on the right? There's no repeating. When you're ready, let's flip to the back. It says a wave has a maximum of 6. If its midline is at y equals 1, what is its minimum? So I love to play the game, what do I know? So I'm going to write those things down. I know that it has a maximum of 6. It tells me I have a midline of y equals 1. And I want to find the minimum. So if you flip back through your notes in this packet, we have something about the midline. See if you can find it. The midline is y equals 1/2 the maximum plus the minimum. Be careful that you have the plus sign. Don't get it mixed up with the amplitude. The midline is y equals 1. I know the maximum is 6, and then I'm looking for the minimum. So let's call that minimum x, or y, or z, or any letter you like, or question mark. It's the unknown. So this is going to be 1 equals 3 plus 1/2 x. Subtract 3, I get -2 equals 1/2 x. And if I want to clear the fraction, I can multiply both sides by 2, and I get -4 equals x. So guess what? That unknown is my minimum. The minimum is -4. So again, what I did is I reread the problem and I asked myself, what do I know? I know the maximum is 6. I know the midline is y equals 1. Well, I know something about the formula for a midline is y equals 1/2 maximum plus minimum. I plugged in y equals 1 and the maximum is 6, and then the only thing missing was the minimum. So I was able to do that. All right, on this page, what I want you to do is I want you to pause the video and seriously pause it and read each set of directions, look back through the notes, try each one, and then I am going to rather quickly work these out. But it's with the understanding you have paused the video and you've attempted it. Please, please make sure you pause it. All right, in 7 through 9, so here I go. It says identify one cycle in 2 different ways, then determine the period of the function. So one of the ways to do this is if I start at x is 0, my tick marks are going by 2s. So I could start x equals 0 to x equals 5. That would be one way to do that one. Or I could start at x is 2 to x is 7. So that's what I mean by identify one cycle in 2 ways. Then determine the period. So no matter which way I do it, the period is 5. All right, number 8. I went from x is 0 to x is 4. That does the job. And these are not the only answers, okay? You could use other options. So you could go -2 to 3, or excuse me, -1 to x is 3. So the period length is 4. On this one, I did x is 2 to x is 6. I also did x is 0 to x is 4. So the period length is 4. In 10 through 15, these should actually be pretty quick, yes or no. Determine whether each function is or is not periodic. If it is, find the period. So what I would like you to think is, could you take a stamper and take that region, that cycle, one full cycle, and keep stamping, stamping, stamping? So number 10 is a no. 11 is a yes. It starts here, and then it's going to repeat here. So 2, 4, 6, 8, 10, 12. So the period is 12. Number 12 is no. 13 is no. 14 is yes. Finding the period, you know, I usually start with my hills or my valleys. So it looks like it's going from, and if it helps, x is 1 to x is 9. So that's going to have a period of 8. Like I usually do the hills or the valleys, or the max or the mins. Number 15, this one's a little bit confusing, but it's actually yes. If you start here, then it is going to repeat. It really does repeat here. So that's going from x is 0 to x is 7. Hopefully you can see that. All right, last group. Find the amplitude of each periodic function and the midline. So remember, amplitude is half the difference between the max and the min. So write down the maximum looks like 4. The minimum is negative 4. So the amplitude is 1/2 the difference. So that's half of 8, which is 4. It also asked us for the midline. The midline is different. It's an equation. So that's going to be y equals 1/2 4 plus negative 4. Well, that's 0 and half of 0. Do you see that if I drew the midline up on this graph? It's halfway between, which is y equals 0. So that's pretty cool. All right, make sure now if you needed help with this one, pause the video and try this. Now, if you already paused and you worked them all, keep listening just to check. So here in number 17, my maximum is 2. My minimum is negative 4. Okay, be careful. The ticks are 2s. So the amplitude is 1/2 the difference between the maximum minus the minimum. Half of 6 is 3. Okay, that becomes 2 plus 4. The midline is an equation. So it's y equals 2 plus negative 4. Half of negative 2 is negative 1. So see that? The midline is half the distance. It's halfway between your max and min. So if you look at 2 to negative 4, that's 6 units. I want to go down 3 from that maximum. So that's pretty cool. All right, last one. Number 18, the maximum. Let's check the tick marks. Uh-oh, this one, the tick marks are going by 1s. So the maximum is 2. The minimum is 0. Okay, check those tick marks carefully. So the amplitude is half the difference between the maximum and the minimum. Half of 2 is 1. So my amplitude is 1. The midline is an equation, y equals the maximum plus the minimum. So it's y equals 1. And think about that. If I could draw the midline here, it would be at y equals 1. That concludes the 13-1 notes.